Summative 10 is going to start out with two old topics that we're going to retest. I was not real happy with the last time we tested this, and the first is our right triangle trig, or SOHCAHTOA questions. On the review I put a couple extra questions that you're going to have to fill out something like this on the test, so make sure you know what formulas I'm asking for. But first let's get straight what the vocab is. So if you have a right triangle with an angle at either of the corners, let's say our angle is here, then you should be able to tell me who the adjacent, opposite, and hypotenuse are. So this is clearly the hypotenuse because it's the longest part of a right triangle, or it's across from the 90-degree angle. And then this leg here is adjacent to the x, or to the angle, because it's next to it but not the hypotenuse. And then this side here is opposite because it is directly across from the angle, not next to it. So the ratios that I'm asking you to fill out here, and you can abbreviate, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So some of us had so many problems on these questions I couldn't tell even where to start with what concepts you were missing. So ideally you just get these questions right this time, but if you are making a mistake, I want to find out if it's just you're labeling your triangle wrong, or you're using the trig ratios wrong, or maybe you're just typing in your calculator wrong. Speaking of calculators, make sure you are in degree mode. Some of our other classes are using other modes, so make sure you check that you're in degree mode. And on these applications, I'm going to be asking you to label the diagram correctly, set up your trig ratio, and solve it. So, tree, there's a tree, and it casts a shadow. One issue we had on the last test, some of you forgot where shadows are located. They are on the ground. So here's our tree. Yep, that's a tree. And then our shadow is 8.4 meters on the ground. And it says the angle of elevation is 17 degrees. So the angle of elevation and the angle of depression are actually the same angle. They're just located in two different spots. The angle of elevation is down on the ground. If they ever say angle of depression, it's the same size, but it's out here outside of the triangle, and that's why we can't use it in our trig ratio. So they want to know the height of the tree. You can call that whatever you want, but it's unknown, so it's a variable. And then what I'm going to go through is I'm going to label from this angle, which is the angle we're using in our trig ratio. This is the adjacent side, and this is the high. No, it's not. I should have used H. That's confusing. Let's use X. That's the opposite side. So that trig ratio is a tangent. So we're going to set up the tangent of the angle is opposite over adjacent. And then to solve trig ratios, we cross multiply this proportion. So it's X equals 8.4 times the tan of 17, tangent of 17 degrees. So show me what you're typing in your calculator. That'll help some of you out with some scores if you happen to type something wrong. And then I undo it, so I don't know what answer that is, but it's something. Okay. Pause for a moment, I'll go find it. Alright, so I found my key, I did the work, and this comes out to 2, I think it says 2.57 meters. I can't really read my handwriting. That might be a 5.1. I can't tell. Either way. Type it yourself, make sure you know what you're typing. Alright, so here we have an altitude, which is fancy talk for height, of a hot air balloon. There we go. Yep, totally, hot air balloon. That looks like a balloon. Has an altitude of 675. And the angle of depression is 25 feet to the 25 degrees to the landing spot. So, when they say angle of depression, they're referring to up high in the sky, out of the triangle. This guy right here is 25 degrees. But angle of depression cannot be used. You have to rewrite it down here at the angle of elevation for your picture. And they want to know the horizontal distance to the landing spot. So horizontal measures left to right. They want this part right here. So if this is now my angle that I'm going to use in my trig ratio, this is the, oh gosh, that's the adjacent. And when I see these notes on your paper, and if you have a misconception like I almost had for a moment, I can be a little more lenient on your grading when I see what you were thinking. So we have tangent again. So we have tangent of 25 degrees equals opposite over adjacent. Now be careful on this one. Sometimes kids think these are all multiplying questions. This is a cross multiplying question. It actually turns into a division question. You get x times the tangent of 25 equals 675. So what you actually end up typing in your calculator is 675 divided by the tangent of 25. So when I typed that in, I got 144. No, I did not. I got 1,447.5 feet. There we go. All right, moving along. This time you have a 250-foot tower, and it's got a supporting cable that it anchors to the ground. So that was supposed to be vertical, but it's not. Use your imagination. Now, label this one carefully because the wire is 300 feet long. So that's actually this part here, because this is the tower, this is the wire. And they want to know the angle that the wire makes with the ground. So they want this angle right here. So this is my angle of reference for my math. This is the opposite side, and 300 is actually the hypotenuse. So we're going to set up a sine ratio. So the ratio works as sine of the angle, which I don't know the angle, so sine of x equals opposite, that's a 250, over hypotenuse, 300. And then this is not a cross multiplication question because you're trying to solve for x, which is trapped inside the sine function. So what we're going to have to do is undo the sine function by typing an inverse sine of this ratio. So angle x equals, looks like 56.4 degrees. Please practice typing. Many of you who got a poor score on this section last time just had no clue what to type in, and that was part of your issue. All right, again, this is a repeat section, so we're going to do better this time. It's the dreaded clock problem. So S represents arc length, so distance traveled around a circle or around a sector sometimes. R is the radius length of the circle. Theta is the central angle, but remember it has to be in radians. So that was the issue for some of you last test. It has to be in radians. Don't confuse radius length with radians measured. Different. And then A represents the area of the sector. So one question will ask you for arc length. Gave you the formula. One question will ask you for area of the sector. So the clock problem was the major issue for most of you. So we have a clock with a minute hand that is 11.5 inches long. That is your radius. And then, like on the last test, I kind of walked you through the math, so you're going to have something similar here. It's going to ask you how many rotations the minute hand made. So from 7 a.m. to 1 p.m., that is 6 hours, right? So 6 hours means it made 6 rotations, or I think I call them revolutions on the test. But then it's going to ask you for theta. So theta is the angle, and we're talking full revolutions, but remember it has to be in radians. So what you're going to need to do is take the number of revolutions and multiply it by 2 pi, because 2 pi is a full circle when you're measuring in radians. This way we don't have to convert at the end. So for us, that would be 6 revolutions times 2 pi. I would prefer you guys just to leave this as 12 pi right here, but this is just theta. We haven't actually found the answer yet. 12 pi radians. If you want to type that in, you can. So finally, it's going to say, now find arc length. So the formula is r times theta. So radius is 11.5, and we just found theta to be 12 pi. Some of you forgot the pi last time, so watch out for that. And this is 433.5 inches. All right, I'm going to skip the next clock question because it's the same, so please try it yourself. And then I'll do one of these area of a sector questions. I'll do the sprinkler one this time because everyone groans about the puppy fertilizing question. Our sprinkler shoots out 17 feet and rotates at an angle of 95 degrees. So there's going to be a blank in your test that says theta equals something radians. And then it's going to say like radius equals. So the radius is how far out the water is going to shoot. The radians was the problem for some of you. So some of you wrote 95 degrees here. It's not correct because that's degrees. We got to convert it, right? So it's 95 times pi over 180 is our conversion factor that we use. So that's what goes up here in the radians blank. So I reduced it, as I always reduce that, and I got 19 pi over 36. So this is 19 pi over 36. Again, you can write the decimal version of that if you went ahead and typed everything in. Just watch out how much you round. So now we're ready to use the formula. The formula is 1/2 times radius squared times theta in radians. And then when I type that all in with the pi included, I get 239.6 feet squared. Our final section on this test is going to be basic trig graphing for sine and cosine functions. So I'm going to ask you a whole bunch of stuff at the top of this section, and you're going to have to fill it out on the test as well, so make sure you know what I want. So dependent on whether it's sine or cosine, a lot of this is going to be the same. So first I want to know what this a represents in the formula. So remember, a is the number that's in front of your function. So what I'm going to do here is I'm going to write absolute value bars around the a, and then say that it represents the amplitude. Because remember, it's the power of the wave, so it's not negative, it's always positive. And then what does this b represent? Well, it changes the period, because it's going to be used in this next formula. So whatever number is inside the cosine function or inside the sine function, if it's not a 1, it's going to change the period length using this formula. So the formula for period is 2 pi over b. And then we simplify that, of course. And then how do you find quarter points? Well, you take whatever the period was and you quarter it, so you divide by 4. The other thing you're going to need to know off the top of your head is a general shape for cosine and a general shape for sine. So cosine is the one that starts at the maximum line and then makes like a horseshoe shape. Sine is the one that starts at the origin and then makes this shape, kind of. It's ugly. Alright. Alright, so using all these formulas, we're going to apply that to an actual function. So here the amplitude is the absolute value of this leading number, so it'd be a 3, which tells me how to label my vertical lines. So our basic functions are always going to have a midline at 0, and since the amplitude is 3, the top maximum line is 3, the minimum line is negative 3. And then b, remember, is the number inside the cosine function in front of theta. There is a number there. There's a 1 in this case, which means the period doesn't change. The formula for period was 2 pi over b. So 2 pi over 1 is still going to be a 2 pi. And then the quarter point is where you take the period you just calculated and then quarter it. So 2 pi over 4 reduced would be 1/2 pi, or pi over 2. So that's the quarter point. That's what we're going to count by. So this is going to help me give you the best possible grade, the one that you deserve, because if you have a miscalculation here but you use it properly down here, then I can give you a 4 instead of a 3. So we're going to have to label. The origin is 0 for the x-axis, or the theta axis. And then we're going to count by 1 pi over 2. So 1 pi over 2, and I don't mind if you keep it as 2 pi over 2 for now, and then 3 pi over 2, and then again 4 pi over 2. We're going to come back right now and reduce it though. 2 pi over 2 is pi, and then 4 pi over 2 is 2 pi. And then the thing I check is if the period is 2 pi, that means I should be ending at 2 pi, so I did something right. And now I just have to remember the shape. So this is a cosine graph, which means it starts up at the maximum and then travels along with the pattern. Alright, so I kind of missed my point there, but you know what I'm going to do is make a really big point. There we go. Alright, moving along here, we have a -1 in front of the sine function. So when I ask you for the amplitude, please don't be tricked, because remember, it's the absolute value of this number. So the amplitude's really a 1, but it has been reflected. So I'm going to make myself a little note. Hopefully, I don't know why it went to the black ink all of a sudden. Hopefully I remember when I go to graph. So midline 0, and we got a 1 and a -1. Inside the sine function, there's a number, and that's b. Now be careful on this one. The calculation for period is 2 pi divided by b. So if you divide by a 1/4, you have to remember that that means you're multiplying by the reciprocal, which is multiplied by 4 over 1. So the period's actually 8 pi. And then if you quarter that, you take the period and you quarter it. So we're going to count by 2 pi's. So this being 0, and if I count by 2 pi's, that's pretty easy. 2 pi, 4 pi, 6 pi, and 8 pi. And then I'm not going to forget, remember this is sine, but it's reflected. So it still starts at 0, but instead of going up, we're going to go down to the minimum. And then I know some of you felt this was a really easy set of lessons when we learned how to graph these. That's awesome. I just would like you to make some mental choices here at the end of your problem. Check that your period's ending at the right spot, make sure all your axes are labeled, and that your shape is correct. Alright, 3 sine 2 theta. So this time the amplitude is a 3 again. So 0, 3, and negative 3 are my labels on the vertical axis. And then the b value is the number inside the sine function, so it's a 2, which will change the period, right? The formula is 2 pi over b, so 2 pi over 2 is pi. So that's the end of the cycle, but we need to find the quarter points. So you take the period and you divide it by 4. So pi divided by 4, that's what we're going to count by. So after 0, we have 1 pi over 4. You can write this as 2 pi over 4 for now. 3 pi over 4. And 4 pi over 4. Thank you. So going back and reducing, 2 over 4 is half. So let's call that pi over 2. And then 4 over 4 is 1. So this is just pi. Alright, I'm graphing a sine this time, and it has not been reflected. So it still starts at 0. This time it's going to go up. Ooh, move. Oh, man. I missed. Okay. Let's try the last one here. Oh, fun. Alright. Negative 1/3 is in front of the function, but remember it's the absolute value of that number is my actual amplitude. However, it has been reflected. So, 0 is still my midline. 1/3 is my amplitude, so that's positive 1/3 and that's negative 1/3. What I like about unlabeled graphs is you can label them whatever you want, so I prefer them to be that way. Remind me that it's reflected, class. So b is the number inside your cosine function, so that is b, 4. So then we're going to take the period, or find the period by taking 2 pi and dividing by b. So 2 pi over 4 is going to reduce to 1/2 pi. So that means this last mark here is going to be half pi. So now I got to quarter that. This is kind of tricky, right? So if you take the period and you divide by 4, that would be pi over 2 divided by 4. Well, we're working with fractions and division, so let's change that around. Instead of dividing by 4, let's multiply by the reciprocal, which is 1/4. So pi over 8 is what we're going to count by. Alright, here we go. 0. This is 1 pi over 8. This is 2 pi over 8. I'm going to go ahead and reduce that to pi over 4. So 1 pi over 8, 2 pi over 8. This must be 3 pi over 8. And I was pretty sure this was supposed to be 4 pi over 8, but that is pi over 2. So it's a good feeling at the end of the question when you know you did it right. Now be careful. We have a cosine, which starts at the max. However, it's been reflected. So instead of starting at the maximum, it's going to start down here at the minimum. And then progress from there. Lovely. Alright. Oh, man. Yeesh. Okay. My pen got away from me. There we go. That was really, really ugly. Okay, so here's what I want to see. Labeled axes, all that stuff filled in at the top. So if you have a miscalculation versus a concept miss, I can tell the difference, right? The shape should be appropriate. Don't make them look like mountain peaks, like V's. They're curvy and waves. And that's kind of it. All right, so that's a new topic. I'd like to be done with graphing after this, guys, because frankly, we're just running out of time. So give it your best go and pull those grades up right before finals.